So the reciprocal ratios, or sometimes they're called the secondary trig ratios, are the reciprocal ratios of sine, cosine, and tan. So CSC is the, let me fix my screen here. My screen was not working great this morning. I think maybe because no one's used this for a week. Let's see how it goes. Okay, so CSC is the abbreviation for cosecant. And cosecant is the reciprocal of sine. So sine we know is opposite over hypotenuse, and so cosecant is hypotenuse over opposite. Okay, then CE or SEC is the abbreviation for secant, and secant is the reciprocal of cosine. And then COT is the abbreviation for tan, and it is called cotangent. And so tan is opposite over adjacent. Oops. Doesn't like this side of the board. And so cotangent is adjacent over opposite. So we looked at graphing sine, cosine, and tangent the other day. And now we're going to look at graphing cosecant, secant, and cotangent. Okay, so let's do cosecant. Okay, so remember that cosecant is the reciprocal of sine. So if you were making a table of values, to find your y values, you would do 1 divided by sine theta. So you could make a table of values like we did with sine, maybe going every 45 degrees. So if I were doing starting at 0, I would do 1 divided by sine of 0. Then I would do 1 divided by sine of pi over 4. And then I would do 1 divided by sine of 90, and so on. So I could do my table that way. I'm going to show you a quick way to do these. It's just easier. So what we're going to do is we're just going to start by plotting the points as if we were doing sine. Because remember, it is the reciprocal of sine. Okay, so sine starts at 0. Let's put in 1 and -1. We'll put in our max and min here. So sine normally starts at 0. At pi over 2, it's at its maximum at 1. At pi, it goes back to 0. At 3 pi over 2, it goes down to -1. And at 2 pi, it goes back to 0. So I'm not going to join these points. I'm just plotting in where sine would be. Okay, and then I'll continue to the left. So 0, 0. At negative pi over 2, it's down to -1. This graph's a little bit off. Then at pi, it goes back to 0. At -3 pi over 2, it's up at 1, and then back to 0. So that's where sine normally is. Now let's think about this. If I want to do cosecant of 0, well, cosecant of 0 is 1 divided by sine of 0. And sine of 0 is 0. I can see that on my graph. Well, we can't divide 1 by 0, so we get an undefined answer. Okay, so at 0 we get an undefined answer, which creates a break in the graph. So I'm going to indicate the break by a broken line, which is somebody's on some. Okay, thank you. All right, so at 0, we've got 1 divided by sine of 0, which is 1 divided by 0, which creates an undefined answer. And so we have a break in the graph, or a vertical asymptote. Okay, that would occur again when it's pi. Because if I do 1 divided by sine of pi, well, sine of pi is 0. And that creates another undefined answer. So whenever the value of sine is 0, it's going to create a vertical asymptote. It's going to create a break in the graph where there is no value. So that's the first thing I'm going to draw in. I'm going to look at all the points where sine was 0, and I'm going to draw in my vertical asymptotes. Okay? The next thing I'm going to do is look at the max and min. So think of these as we're doing the inverse, right? So if it is a max, normally I am having a max between 0 and pi. This will become a minimum value. So instead of turning down, it will turn up. The same with my negative one. Instead of turning up, it's going to turn down. And likewise over here. So at negative 1, it's going to turn down. At positive 1, it's going to turn up because we are drawing the inverse. So that's what my cosecant graph looks like. I'm going to start by finding the zeros, drawing in my vertical asymptotes, and then I'm going to inverse the rest of the graph by turning anything that's down is going to go up, anything that's up is going to go down. Okay? Are there any questions on that? So drawing it. So let's talk about the domain and range. I'm just going to write it here. So we're only going to state the domain and range over the interval 2 pi to negative 2 pi. We're not going to go on forever. There is a way to write it because it does repeat, but we'll just do it over this range from 2 pi to negative 2 pi. So my domain for x will be any number, but there are points at the graph that are not possible or undefined. So we're going to list those points where x is undefined, and that would be where our vertical asymptotes appear. So we say x can be anything, but it does not equal 0, pi, 2 pi to the right, and then I'm going to put a positive negative. Oops, well, my smartboard's not cooperating, so I'll just write it out. So 0, pi, 2 pi to the right, negative pi, negative 2 pi to the left. So x can be anything but not these numbers. Okay, then my range, y can be anything. But be careful with the range because we have numbers. So starting at 1 and going above 1, or starting at negative 1 and going below negative 1. So think about this. You cannot have a number that is above 1 and below 1 or negative 1 at the same time. So we have to write it as two different statements. It's either below negative 1 or above 1. So we can't write that statement as one statement. We have to write it as two separate statements because the graph is divided into two parts. Okay, it's either up here or down here. Okay? All right, so that's cosecant. So we are going to follow the same process with secant. Let's make sure there's no questions here. I don't see any. Okay, so we're going to follow the same process with secant. Okay, so secant, remember secant is the reciprocal of cosine. So if I were doing a table of values, I would do 1 divided by cosine theta to find my values. Okay? Or we can start by plotting the points. I'm going to try fix the screen one more time. Okay, let's try this again. All right, so we're going to Put in 1 and -1. Okay, so we're going to start by plotting where cosine would normally be. So cosine normally starts at 0, 1, goes down to 0, pi over 2, down to -1, back to 0, back to 1. And then I'll continue on the left, middle, bottom, middle, top. So there's cosine. Okay, I'm not going to join it together. I'm just going to plot the points. Now, where does cosine hit 0? Because if I'm doing secant, so let's say I'm doing secant of pi over 2. Well, secant of pi over 2 is the same as 1 divided by cosine of pi over 2. And I can see from my graph that cosine of pi over 2 is 0. And so that gives me an undefined answer at pi over 2. Likewise at 3 pi over 2, which would be 1 divided by cosine of 3 pi over 2. And I can see from my graph that cosine of 3 pi over 2 is 0. That would also give me an undefined there. So anywhere there's a 0, again at negative pi over 2, and again at negative 3 pi over 2. So wherever there's a 0, that's going to create a vertical asymptote. Any maximum becomes a minimum, and a minimum becomes a maximum. So they turn upside down. Okay, so a minimum becomes a maximum, and a maximum becomes a minimum. So there's my graph of secant. So it looks just like cosecant, except the vertical asymptotes are in a different location. Just like sine and cosine look a lot alike, except they start at a different point. They're shifted. So x is any number, and I'm just going to list the places where it's not valid. So at pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2. And then my range is the same as cosecant. Y is any number, but it is always above 1 or less than -1. Okay? So that's the easiest way to do sine and cosine. And then we'll have a look at tan. Just going to move this up a bit. Make sure this is in the right order. Okay, so let's do cotangent. So cotangent is the reciprocal of tan, and I typed that in wrong there. This should say start by graphing tan. Okay, so remember tan's a little bit different. Okay, so I'm going to draw tan down here. Just because tan had some vertical asymptotes, if you remember. So 2 pi, pi. Okay, so if you remember tan, we talked about as we went around the circle, right? Because that's what we're plotting. We're plotting our points as we go around the circle. When we got to the top of the circle, so tan of pi over 2 was 1 over 0, so undefined, right? So that created a vertical asymptote there. And then that also happened at the bottom of the circle at 0, -1. So tan of 3 pi over 2 was -1 over 0, also undefined. Okay, so our tan had asymptotes here. And then again, on the left side. And then in between the asymptotes, it was 0. So it was 0 here, 0 here, 0 here, here, and here. And then it approached the asymptote from each side. So down to the left, up to the right. And it looked like this. Okay, so that's what my tan looked like. So cotangent, we're going to do the inverse. So what I wanted to know is, well, where was tan 0? Because that's going to create vertical asymptotes on my cotangent. So tan was 0, at pi, and at 2 pi. And then to the left at negative pi and negative 2 pi. So that's where my vertical asymptotes will be on cotangent. So when you're doing cotangent, you might want to sketch tan because it's not as obvious where it's 0. And that will be my vertical asymptotes on cotangent. And then it will be 0 halfway in between, just like tan. It hits 0 in between the asymptotes. But the graph, instead of going up to the right, it's going to go down to the left, or down to the right, I should say. So it'll look like this. So it's going in the opposite direction, because remember, we're doing the inverse. So that's cotangent. Okay, so cotangent is a decreasing graph, whereas tan is an increasing, and the vertical asymptotes are in a different spot. Okay, and so domain and range. So we'll say x is any number, but not at, erase that, not at 0 pi in both directions and 2 pi in both directions. And then the range is anything, right? Because the range is continuous. It goes forever up and forever down, okay? So no restrictions on the range. So when you are being evaluated on graphing, you will have to draw all 6 graphs, right? You have to be able to draw sine, cosine, tan, cosecant, secant, and cotangent, and state the domain and range. You will only have to transform sine and cosine, okay? You will not have to transform any of the other reciprocals or tangent, okay? Any questions on that? Okay, I'm going to do, what time is it? 1:05. So I'm going to do one beginning lesson on transformations, okay? Just to get people started if they're there. So if you remember your transformations starting in grade 10, this is the general equation for transformations. Okay, and we talked about this back in Unit 1. Anything outside the brackets is a vertical transformation. Anything inside the bracket is a horizontal transformation. So that was one rule. Right? So outside the bracket is vertical, inside the bracket is horizontal. Anything multiplied is a dilatation or a stretch or compression. Anything added or subtracted is a shift. And likewise with the vertical, anything multiplied is a stretch or compression. Anything shifted or anything added or subtracted is a shift. Okay? The vertical stretch in trigonometry is referred to by a different name, the amplitude. The vertical shift is the vertical shift. The horizontal shift is also the phase shift, right? So it's just a different name. Horizontal stretch affects the period. It's not the period, but it will stretch the period, right? So the normal period is 2 pi, and then that will be divided by whatever that value of c is. And so we would ask that you state any amplitude, period, horizontal shift, vertical shift, and then you're going to do your mapping notation. Okay? So the amplitude in this question is the a value, which is 3. So it has a vertical stretch of 3. It has a value, C factor of 2. So the normal period of 2 pi is going to be compressed by 2. So it will be pi. So this graph will finish one cycle in pi instead of 2 pi. Okay? The half meaning you're only going to get in half the graph if you were to go to the, double if you're going to go to the regular 2 pi. You'll get it in twice. There is no phase shift and there is no vertical shift. So there's only a vertical stretch and a horizontal compression. Okay? My mapping notation explains what I'm going to be doing to the x and y coordinate, how I'm going to change it. So the number that's inside the equation, the 2, the cosine, between cosine and theta is 2. That's my c value. Remember that x or horizontal transformations always do the opposite or the reciprocal. So 2 will change my x by a half, and then the 3 applies to the y. Okay, so the y is going to be vertically stretched and the x is going to be horizontally compressed. And then I'm going to list those points on sine. Oh, sorry, this is cosine, right? Yeah, this is cosine. So just be careful you get the right ratio. So I'm going to list my 5 points on cosine that I have memorized. These are my 5 critical points that give it its shape. Right, so at 0, cosine starts at 1, it goes down to the middle, it goes down to the bottom, back to the middle, back to the top. So those are my 5 critical points on cosine. I'm going to apply these transformations to those 5 points. So I'm going to multiply all my x values by a half, and I'm going to multiply all my y values by 3. So 1/2 times 0 is 0, 3 times 1 is 3. 1/2 times pi over 2 is pi over 4, and 3 times 0 is 0. 1/2 times pi, and then we have 1/2 times 3 pi over 2, and then we have 1/2 times 2 pi. So the points in red are the points I want to plot. And the nice thing about mapping notation is that I can see what I'm going to graph before I actually graph it. So I know how to divide up my scale on my axes, right? Remember that your graph means nothing if you don't have any numbers on it, right? If you give me a blank graph with some points and there's no scale on the x and y axis, it doesn't mean anything because I don't know what you're graphing, okay? So I can see that I need to divide. I look at the lowest denominator, which is 4. So that means I need to divide my scale by quarters, right? It's just easier to graph. So I might say every 2 squares is pi over 4. Right? So this would be pi over 4, pi over 2, 3 pi over 4, and pi. And I'm going to do the same to the left. You need to be able to get in 2 cycles. It doesn't matter whether you go 2 cycles to the right or if you go 1 cycle to the right and 1 cycle to the left, as long as you get it in twice. We have to go up to 3 and down to -3. So starting with the first point, pi over 4, it goes down to 0. Pi over 2, it goes down to -3. And so there's 1 cycle. Put an arrow so it's continuous. And then I will continue that to the left. So there is 2 cycles of my graph. And then I'm going to just check my graph to make sure that it seems relevant to what I'm trying to graph. So my amplitude is 3. So here's the middle. And this is 3 up and 3 down. So my amplitude is correct. The period is supposed to be pi, and it is. It starts at 0, 1, ends at pi and 1. So the period looks okay. So my graph looks like the transformations are relevant to what I was trying to graph. Okay? So the other thing about mapping notation, and I will ask for it, is that I can see even if you graph it incorrectly, I can still see what you were trying to graph. So if these points here are correct, then you're going to get most of the marks, even if your graph was wrong. Because I know you were trying to graph those points. Maybe you put your scale wrong or whatever, but at least I know what you were trying to graph, okay? So that's the importance of the mapping notation. So these types of questions, you're going to be asked to state the properties. So amplitude, period, phase shift.
Please excuse the interruption. If Ari Hader, please come to the main office. Ari Hader to the main office, please.
So you'll be asked to state the properties, you'll be asked to provide mapping notation, and then you'll be asked to graph 2 cycles of the graph. Okay? So on Friday, we will continue doing some graphing. Okay, today, for the rest of today, I would like you to try on your own to graph the reciprocal ratios, thinking about what we talked about. So kind of cover it up or don't look at it. Go try and graph them and see if you can state the domain and range, and then go back and check the lesson to make sure that you are correct. So I'll just put these up here. Okay, so there's cosecant, so you can go try graph it and then check and make sure that you are correct.